I'm late. All right, let's see here. Okay. Wait, register. I thought I was registered. Okay. Q1. You're given a positive integer n representing an n by n city. Oh, that's cool. You're also given a two-dimensional grid buildings where buildings phi equals xy, denotes unique building located at coordinates x, y. Why does it start at medium? Do they not do easy problems anymore? A building is covered if there is at least one building in all four directions. Left, right, above, and below. Return the number of covered buildings. What? Okay, well, maybe they've just decided to call easy problems hard. So, buildings equals set of x comma y for x comma y. Yeah. Building set. BS. Okay. All right. CNT equals 0 for x comma y in BS. Okay. If x comma y in BS. Okay, we'll need 4 of them. 1, 2, 3, 4. Right. This equals 1. So up, down, left, right, right? Okay, 1, 1, 0, 1. Uh-oh. Oh. So it doesn't have to be immediate. Oh, that is harder than I thought. Okay. Rows equals default dict of list. What are you doing? Copy the line. Okay, columns equals default dict of list. For x comma y in BS. So x is going to define the column, right? So insort columns of x comma y. It's really annoying that it won't copy the line, but whatever. Okay. So it can't be the most extreme in any row or column, in other words. So my column equals calls of x. Okay. My row equals rows of y. If length of my column equals 1 or length of my row equals 1, then actually, if it's less than 2, then we're hosed. Then if my call of 0 equals y, or my call -1. So, in other words, if it's on one of the boundaries, continue. My row. And if none of those things are true, then CNT plus equals 1. Return CNT. Okay, so 1, 0, 1. 1, 0, 1. Nice. All right, sweet. Okay. Hopefully this goes better than my last competition. That's all I'm saying. Okay. Path existence queries in a graph 1. You're given an integer n representing the number of nodes in a graph labeled from 0 to n minus 1. You're also given an integer nums of length n sorted in non-decreasing order and an integer max diff. An undirected edge exists between nodes I and j if the absolute difference between nums I and j is at most max diff. Okay. You're also given a two-dimensional integer array query. Oh my god. For each queries I, u, I, vi, determine if there exists a path between nodes ui and uv. Okay, the absolute difference between nums I and nums j is at most max diff. Return a Boolean array answer, and answer I is true if there exists a path between ui and uv. LRU cache none. Wait. Is connected. I, comma, j. Okay. So if I is less than 0, or I is greater than or equal to length of nums, or j is less than 0, or j is greater than or equal to length of nums, return false. If I equals j, return true. I don't know why they would, but whatever. Just getting our base case here. All right. Answer of I is true if there exists. All right. The absolute difference between nums I and nums j. Is at most max diff. Everything could potentially be connected with everything else, right? It almost seems like we need to sort nums I and nums j. And then we could see what's in either direction, right? Yeah, but there's going to be a finite number of queries. We just have to, you know, traverse the path once. Break it off into groups, right? Groups would propagate with things that are connected. 10 to the 5th. Can we compare all of them once? I don't think we can. Yeah, but I don't think we need to either. Because things are either going to be connected or they're not going to be connected. All right. Node I and node J. Wait, nums is sorted in non-decreasing order. Oh. So it is already sorted. Okay. So let's just try to think through this rationally. It's going to be able to leapfrog at most max diff from its position, right? And it can do that repeatedly. And there's no reason to not go as far as you possibly can. Interesting. What a weird graph. Okay. Well, I still think we want to do this. Okay. I don't think we need LRU cache. All right. So let's just say by definition J is higher. So if J is lesser than I, then I comma J equals J comma I. We'll just flip it. So now J is bigger. Now if nums of non-decreasing, here, let me see. So they're getting bigger, yeah. So nums of J minus nums of I is lesser than or equal to max diff, then obviously they are connected. Otherwise, we need to iterate. And we will do that by bringing J down as much as we can. So min acceptable value equals, well, simply max diff. No, I got it backwards. The minimum acceptable value is, okay, if max diff is bigger, then this number should be smaller. So yeah. And if nums J is higher, then this number should be higher. So it goes here, like that. Now we want to bisect left nums comma min value. And we know that the max that it could possibly be is J. No, it has to be I. Is that right? Why does it say Leetcode? That was annoying. Okay. Bisect left, high. High is inclusive, right? Bisect left high equals I. Let's not say high. No. All right. Okay. New J equals that. Okay, what is that going to do? So If new j is greater than or equal to length nums, then just return false. Obviously, I mean, that doesn't even make sense. Okay. If it's gone off the bottom, if it's less than 0, then nj equals 0. All right. Now, while nums of I is lesser than min value, no, nums of new j, not nums of I, then new j plus equals 1. Okay. We know that it would have to get bigger, and the diff is always positive, so. Okay. Is this gonna give us some weird thing where like it's the same value over and over? No, because it's either gonna find the value or it's not. I mean, those are the only two options. I think instead of a while, we want an if. That's clearer. So if nums nj is lesser than min value, then okay, now we test it. If it reached something, then so if it is greater than or equal to min value, I'm really paranoid that this is going to do something weird. And it's less than no, this is how we do it. If new j is lesser than j and nums of nj, then we do it again. Then return is connected I, comma, new j. Otherwise, we return false. So we either reach a base case or we end. And it wants a list of bools. Is this going to work? Return is connected I, comma, j for I, comma, j in queries. Is that right? Okay. True, false. False, false. Null, null. What is this null, null business? This always returns something, doesn't it? Oh. False, false, true, true. All right. No. Crap. Okay, this is probably a little silly, but I'll just try it. Try the quick fix. Hidden for this test case is not valid. If I click speed up, will it pass? Memory limit exceeded. Well, that's annoying. Okay. So let's say left equals 0 times, well, no, let's not say 0, equals, I don't know, times length of nums. And then, obviously, left of 0 equals 0. Okay, and then we're going to have minimum value equals for j in range length nums. Okay, the min value equals nums of j minus max diff. Okay. So I equals, well, 0. Okay. While nums of I is lesser than minimum value I plus equals 1. And then once we're done, then we say left of j equals left of I. Min left j, comma j. Okay. So it's more a question of how far it can reach rather than if it's technically connected or something. Because the places that can reach are contiguous, I think. All right, now we're going to say return let's say for I comma j in nums. Crap. Yeah, I don't have the fancy little nums equals sorted ARR for ARR in not nums. So now we know J is higher. Now, this is I greater than or equal to left of j, right? True, false. And false, false, true, true. Okay. Yay. drink after this is done. All right, let's see. Concatenated divisibility. You're given an array of positive integers, nums, and a positive integer, k. A permutation of nums is said to form a divisible concatenation if, when you concatenate the decimal representation of the numbers in the order specified by the permutation, the resulting number is divisible by k. Return the lexigraphically smallest permutation when considered as a list of integers that forms a divisible concatenation. If no such permutation exists, return an empty list. A permutation is an arrangement of all of the elements in the array. Of course it is. Okay, so up to length 13. What is k? Divisible by k. See, now this is interesting. K only goes up to 100. I wonder why they did it that way. There must be some computational complexity if k gets too big. Okay, so not too great with permutations. It wants the lexigraphically smallest one, unless one doesn't exist. Nums of I is lesser than or equal to 10 to the 5th. 3, 12, 45. Oh my god. They're not single digits. They're not single digits. How big can nums I go? Up to 10 to the 5th. I mean, there's trivial cases, but each one of these could potentially... Yeah, but k is capped at 100. Right? If k is 1, then it's just the sorted list concatenated together. If k is 2, then we choose the highest digit or combination of digits, which is itself divisible by 2, and then we sort the rest. Concatenate those together. Can we sort, though? I don't know if sorting works the way we think it does. Because I'm thinking of individual digits. I'm not thinking of these combined digits. It's almost like you need to do a weird sort where it like sorts by the first digit or something. Yeah, because in every case it's going to be choosing the next most significant digit. If I can't even figure out which one is the smallest, then I can't do the divisibility. I feel like I should be able to do this problem. Here, let's take a look at the other problem. Path existent queries in a graph 2. The first one was easy enough. You're given an integer n representing a number of nodes in a graph labeled from 0 to n minus 1. You're also given an integer array nums of length n and an integer max diff. An undirected edge exists between nodes I and j if the absolute difference, so far it seems identical, is at most max diff. You are also given a 2D integer array queries. Find the minimum distance between nodes ui and vi. Minimum distance. The minimum distance would be jumping as far as possible, right? I think that this would be a better use of our time, so. Let's see here. Okay, minimum distance. It would have to jump to a different position, so it's the distance from this to something else. It's how far left, and then each one of those adds one, right? I feel like I feel like this is the same question. Well, it's definitely the same question. Okay. So, if they are connected, then we just jump as far as we want every time? Yeah, jump as far as you can every single time. All right. What are you doing? Losing my mind, apparently. Okay. So. Okay, -1 if I is false, else this is not going to work. If res of I is false, oh, for hell's sake. Return value equals that for I, j in queries, if I is lesser than left of j, then it's almost like we need 2 of these. The can we make it ever, and then the actual, cost. I'll try it with the recursion. If it times out, then I'll modify it. Okay, if it's less than it, then ret.append -1, else ret.append r of I, j, and then return ret. And we're not going to be able to do this. It's almost like it needs to know the furthest it can go in a single jump. Yes, that's exactly what it needs to know. So, furthest single equals left of I. So furthest single of j equals I. Yeah, that's easy enough. All right. If I equals j, then return 0. If I is greater than or equal to clipboard for the single of j, then return 1. Otherwise, return 1 plus r of I, comma, for the single of j. And hopefully this works. So output -1, -1. Example 1. 1, 2, 3. One and 1. Probably not a good start there. So this is really weird. The only place a -1 could come from is if I is lesser than left of j, which shouldn't be possible if they're connected, right? Print left of j, comma I, comma j. Output, where is output? std out 103. So left of I, left of j. So left of j is 1. And we're trying to get to 0. So this is saying all of these things are connected. Oh, nums is not sorted. Well, I think we just got to the bottom of this mystery. Okay, we're going to have to map these. Okay. So adjusted equals enumerate of nums. Is that going to be a list of tuples? Print adjusted. So we need the first value. This is going to be backwards. 0, 1, 2, 3, yes. So we want j comma I for I comma j in, and then that has to be sorted. Okay. So run. Yeah, it's always comparing the differences. So 0, Yeah. 1, 2, 3, 4, 8. So now we will have a mapping. Okay. Mapping equals, I don't know, like that or something. Okay, for new index, comma, I, comma, j, or is it j, comma, I? In enumerates adjusted. This should map the new values to the old values. Is this really the best way to? Yes, 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 because we want to reuse the same code. All right, so mapping of old index equals new index, right? Of course. So show me the mapping. Run. So 0 becomes 0. Yes. 4 becomes 1. 0, 1, 2, 3, 4. All right, I think the mapping is working. So let's come down here, and we're going to say I raw, j raw, and it's going to be I, comma, j equals mapped. I raw, mapped, j raw. Okay. Oh, shit. Oh. Okay. 1, 1. What? 0, -1, -1. Do you know what this means? It means that this stupid thing doesn't work at all. They have deliberately made it so that it is impractical to know every single possible jump. No. This solution should work. There's just a bug in it. Well, that's easy to say. Yeah, it is easy to say. All right. This should work. The only thing that it could do is it could time out. Okay. Do I want to start over again? I think so. This is some convoluted nonsense here. Well, that was depressing. Okay. We'll say H equals list of enumerate nums, because we need to know the original. Something is wrong. That should have worked. Why am I starting over again? We're not going to heapify anything. Sorted j comma I for I comma j in enumerate jumps. Print h. J comma I 0 0 1. Did it even run my latest code? What the hell is this? Yeah, that's right. Looking at the wrong thing. So this is the original index, right? 136 136. You want to jump as far as you can. No question about that. But how are we going to know if we pass over the original mapped value? Well, because the original mapped value has a numerical identifier. And it doesn't matter if we look at the wrong one because the jump would be the same as long as the values are the same, right? Can we do a linear search every time? What is the maximum number of queries? 10 to the 5th. No. If we had to jump one at a time every single time, that would just be too slow. You're going to run into an n squared issue. It has to be a DP table. But how? You can't have a DP table that has every starting point and every ending point. I don't know how to do it without counting them individually. Even if my last code had worked, it would have timed out. Well, this is depressing. I don't think I can do either of the hard ones. Alright, well, I tried.